SRS is what? Software requirement specification. That is a requirement specifications document that will going to have all the necessary requirement which is given by the customer. We have to follow two conditions. One is cohesion and coupling, that you can see here. A good structure design is always follow the rules. How we are going to find the cyclomatic complexity? That too with the help of this formula, that is M is equal to E minus N plus 2P. Hello everybody, welcome back to the session 2 of Software Engineering 6th semester BCA's question paper discussion on the year 2021 November, December. I am Rohini TS, Department of Computer Science, Vidhyaashram First Grade College, the Temple of Excellence, MYSURU. As we all discussed in the last session, we got to know regarding the part A and also have discussed one of the question from the part B. So in our today's session, let me continue with a further question, that is question number 14. So as we all know that each question will going to have two sub-questions. Amongst that, first let me discuss about the 14th question A of I. So it will be for 8 marks question. Explain the requirement engineering process with a neat diagram. So here you can see that requirement engineering, that is in short RE, we have to explain its process with a neat diagram. So what and all you need to write then? So you have to explain what are the different stages we have along with a diagram you need to explain. We'll see the answer for this question. First, let me discuss with a definition. That is what requirement engineering. It's mainly a process of defining, documenting and maintaining the requirements in the engineering design process. So, whenever we are designing any of a software engineering product or a project, at the time what are the different resources or a requirement that we are defining, documenting and maintaining. So, together we have a process, then we are calling that process as what? Requirement engineering process. We are morely focusing on engineering of a requirements which is given by the customer, and here it mainly provides the appropriate mechanism to understand what the customer exactly decides, what they are looking for, and analyzing their needs and assessing its feasibility. Is it possible to develop this software or a project that we are doing it, and negotiating with respect to the time and even money and a reasonable solution, then specifying the solution clearly, validating the specification and managing the requirement as they are transformed into a working system. They are just analyzing everything. If you are developing this software or a product or a project, will it going to satisfy requirements of a customer or not? We are mainly focusing on analyzing of a requirements which is given by the customer, that we are doing in the requirement engineering. So mainly it's a discipline, application of proven principles, methods, tools and notation to describe a proposed system, intended behavior and its associated constraint. All these things will going to be included in the requirement engineering. Then what are the different phases we have? Totally we have a 5-step process. First one is all related to feasibility study. So we have to check, is it possible either functionally or behaviorally, is it possible to develop the given requirements of a customer? That they will be checking in the feasibility study. Next we have a requirement elicitation and analysis. Requirement elicitation in the sense what? By taking a feedback or review from a customer, they are improving it or they are updating those content. And also you can expect this question also. What is requirement elicitation process? This is also one of the important question. And we need to make an analysis of that requirement which is given by the customer. Then software requirement specification. In short, it is SRS. So in this SRS, this is a document which will going to have a complete definition of that requirements, when it will going to be produced, whether it is functional requirement or a non-functional or a user interface requirement. All these data and details will going to be stored in the SRS document, and also it will going to act as a contract between the developer as well as a customer. At last, customer should not say this is what we have not told. So in order to maintain that standards, this SRS document will going to be kept. And also we have a software requirement validation. After the requirement taken from the customer, they are just going to validate it. All the requirements are necessary in order to develop this software, or are we supposed to add any of the requirement in order to satisfy the efficiency of a software? That and all will going to be validated here. That is software requirement validation. Already we got a question with respect to this. What do you mean by validation in a software requirement phase? So we are checking, are we building a right product? That will be done in the validation. After that, software requirement management. So we have to manage all the requirements of a software which is given by the customer. So it's your responsibility to explain each of a process one by one. Fine. Next, here I have given a diagrammatic representation of a requirement engineering. First we have a feasibility study. Once the feasibility study got over, then we are going to get a feasibility report for that. After that, in the next process, we have a requirement elicitation and analysis. Once the requirement elicitation and analysis got over, then we are going to get the system models. After that, requirement specification will be given by the customer, and that can be of user and system requirements. It can be functional and non-functional and user interface requirement. By taking that, they are going to do the requirement validation. If it is validated, then they will come for the requirements documentation or a finalized document. Otherwise, again they will go with a requirement specification. They will take the users and system requirement. Again the purification process will going to takes place again and again until it reaches to the requirement documentation or a final requirement documentation. So this is how this requirement engineering process will going to take place, one phase after another phase. So with the help of this diagram, you need to explain what is requirement engineering. Along with that, you have to explain all the 5 stages in order to get 8 marks. I hope you all understood regarding this question. Let me move to the next question. Explain the components of SRS. So in the previous we got the SRS as a one of the phase. Now here we have to explain its component. When it comes to the components of SRS, then it can be functional components or it can be non-functional components or user interface components. We have a different things in the components of a SRS. First here you can see that SRS is what? Software requirement specification. That is the requirement specifications document that will going to have all the necessary requirement which is given by the customer. Then how it needs to be? The characteristics will be of the SRS or a complete software requirement specification must be clear and hit correct, consistent in nature, coherent, comprehensive, modifiable, verifiable, prioritized, unambiguous. There should not be any confusions and it should be traceable and credible source. Fine. This is how the characteristics of requirement should be. Then also you can see that the software requirement is categorized into some of the categories here. First we have a functional requirements. The requirement which is related to the functional aspects of a software, then we can say that as a functional requirements. Fine. Then they define the functions and functionality within the software system. And here you can see some of the example like search options and user should able to mail. All these are the functionality of a software. Fine. Then next we'll go to non-functional requirements, which are non-functional or which is not related to the functionality of a software. Then we can call that as the non-functional requirements. Requirements which are not related to the functional aspects of a software, then we can call that as a non-functional requirement. They are implicit or expected characteristics of a software. So here we have certain non-functional requirements that include security, logging, storage, configuration, performance, cost, interoperability, flexibility, disaster recovery and accessibility. All these are the different non-functional requirements. So without this, we can't expect more efficiency. Without functional requirements, we can't design or develop any of a software. So both functional and non-functional requirement are important in one another way. And also here we have requirements that needs to be must have. It should be present. Without that we can't do. Should have, it is what somehow optional, but in future we can have it in order to improve the efficiency, and could have, and also we can have a wish list. And also you can see here, we also have a user interface requirement. Then how we are going to communicating with a system. UI is an important part of any software or hardware or hybrid system. So a software is widely accepted. Then how can I consider that as accepted user interface requirement? If it is easy to operate, quick in response, effectively handling operational errors and providing a simple yet consistent user interface. So this is all regarding user interface requirement, and also it needs to be easy navigation, simple interface, responsive, consistent UI elements, feedback mechanism, default setting, purposeful layout, strategical use of color and texture, provide the help information, user-centric approach, and also it is group-based view setting. So all these are the requirements which is related to the user interface. So totally you have to write about functional components, non-functional requirements as well as user interface. We'll move to the next question, that is question number 14, in that the question number B, and that we have a first sub question. What is that? Explain the role of management in software development. What is the role of a management of a software while developing that software? So when it comes to the role of a management, you need to remember 4 P's. What do you have to remember? You have to remember 4 P's here. What is that? One is people. Next, we have a project, process and product. So when it comes to the people, if you consider any stage of a development of a project, we require a human resource. That is what? People. So it's all regarding human resource, personnel. That means it can be analyst, designer, programmer, tester, or even the end users, navigators, whatever it can be. So we all require a people or human resources in all the stages. In this management or a role of management with respect to the people, how they are going to contact and communicate with each other must be managed, so that we all require the information is successfully delivered to the relevant person. For example, if there is no communication between the analyst and designer, designing can't happen. Even analyst is not able to analyze the requirement of a customer if there is no communication between the user as well as the analyst. So people will going to play an important role. And next, what we have? Project. Project is what? Here you can see that from the ideation phase to the deployment phase, we term the process as a project. Process as a project. So here we are considering a process or a set of activities as a project here. So many people will going to work for a particular project in order to build a final product. So that can be delivered to the customer as per their needs. And also in this project we have to think that what we are giving to the customer. So that is what we have to satisfy the requirement of an end user. That is what we will be focusing on this project. And also when it comes to the process is all regarding what? Analysis, process, feasibility study, process. Each phase is considered as a process. That is a set of activities that we are performing in order to lead to the success or a development of a finalized product. That is what we are doing in the process. So each stage is considered as process or set of activities considered as a process here. Designing process, testing process, coding process, all those are the processes you can expect. Next, what we have? Product. So what you have to remember here, in all the stages we have to manage. So if I am not managing the requirement phase or a requirement process properly, then I wouldn't be able to understand what are the requirement of a customer. If there is no communication between the user and analyst, then there is no communication. Then we can't expect the final product or a result. So here, after the development of a process, then we are going to get the complete resultant or a final product. So that needs to be delivered to its customer. Hence the entire process needs a separate management team like a sales department. So if you consider the product, there also management is required. If you don't have a promotion team or a department or a sales department, then who is going to deliver that project or a product to the customer? So management of this stage is also going to be important. Fine. This is how we are going to manage. So this is what for 8 marks. So each project, product, process and people each will going to carry 2 marks. So if you write all the 4 P's here, you are going to get 8 marks from this. I hope you all understood with respect to this question. Let me move to the second question from that subpart. Write a note on software metrics and measurement. This will be for 7 marks. So you can expect software metrics for 3.5 and this software measurement is for 3.5. We'll see the software measurement now. Software measurement is a manifestation of a size, quantity, amount or a dimension of a particular attributes of a product or a process. So we are measuring something with the help of size, quantity, amount or a dimension. And also this is a titrate input of a characteristics of a software product or the software process. Mainly we are having a filtration. We are setting certain standards. If it is matching there, then we are considering that for the development of a process or a project here. It is an authority within a software engineering. So we can set our own standards as a measurement. And also its a process is defined and governed by the ISO standard. So here we have a ISO standard in order to set certain protocols. And also what is the need of software measurement here? So for the create the quality of a current product or a process, to anticipate the future qualities of a product or a process, to enhance the quality and to regulate the state of the project. If you don't have any standards or a set of rules, then it will going to be break. That's what we have to have certain need of software measurement. And this is of 2 types. One is direct measurement, indirect measurement. So if it is direct measurement, we are using some of the standard scale. We are having certain ISO standard to measure the quality of a process or a product. When it comes to the indirect process, it measurement of a quantity or a quality which needs to be measured is measured using related parameter. We have a related parameter in the indirect measurement. We have a standard scale in the direct measurement. Fine. We'll see about the next one, that is metrics. What do you mean by metrics? It's also a measurement of the level that any input belongs to a system, product or a process. It's a potential level of any input which belongs to a system, product or a process. And here also it will going to have 4 functions, that includes planning, organizing, controlling and improving. And what are the different characteristics of a software metrics we have? It needs to be quantitative in nature, should be measurable, understandable, applicability should be there and repeatable. It should be economical, which is feasible with respect to the cost, and it should be language independent. It should not depend on any of a programming language. All these are the characteristics of software metrics. And what is the classification of this software metrics? It can be of 3 types. One is product metrics. So where we are checking the level of input with respect to the product, that is what product metrics. And we have a process metrics. At last we have a project metrics. How many number of developer we are using, what is the time it is taking, what is its cost. If you are checking all those things, then it comes to the product metrics. Whenever we are checking all these things, it comes to the project metric. I hope you all understood. This is how you are supposed to answer for software measurement as well as metrics. We'll see the next question, that is question number 15. Under that we have a first sub question. In that, explain structure design approach. So we have a various design approach here. Amongst that, they are asking you to explain the structure design approach and it is for 7 marks. So we'll see about the structure design. So when it comes to the structure design, it is a conceptualization of a problem into several well-organized elements of a solution. As I told many times, we should not consider a problem as a single unit that needs to be divided into number of units or number of sub-modules in order to reduce its complexity. So here it's a problem into several well-organized elements of a solution. Mainly it's concerned with the solution design. So always this structure design is concerned with a solution design, and it's a systematic methodology to determine the design specification of a software. How we are supposed to design, what are the methodology are we supposed to use, all these will be comes under this structured design. And also it will comprises of 4 components in it, that includes architectural design, detail design, data design as well as interface design. So all these are the different components which comes under this structured design. And what are the benefits we can expect with the help of this structured design? Mainly it will going to give us a better understanding of how the problem is being solved. It's giving a methodology. What is the structure we are using? Are we using top down or a bottom up or a hybrid? All the structures which we are using, how the problem is being solved, everything will comes under this as a advantages of having this structured design. And also this also makes it simpler for designer to concentrate on the problem more accurately. It will going to give us a more clarification or more accuracy with respect to the designing. And also mainly this structured design is based on the divide and conquer strategy. As I told earlier, we should divide the problem into several small problems and we have to find a solution for each problem individually. Then we have to combine all together to get a solution for the complex one. So the small pieces of a problems are solved by means of solution or a solved modules. So each module will going to give us a solution. For example, if this is a problem that needs to be divided into different models, so then I need to find out the solution of each submodules individually. Then we have to integrate all these together to find the solution for the complex task. That's what we are doing in the structured design. Along with that, it mainly emphasizes that these modules will be well organized in order to achieve the precise solution. And also it will going to be arranged in hierarchy. It will be like tree-like structure which I had written already in the previous slide. It can be top-down or a bottom-up or a combination of two as a hybrid. Mainly to communicate with each other, we are just going to use a links. How each model will be communicating with each other will be arranged in the hierarchical format. And in order to explain the structured analysis or a structured design approach, we have to follow two conditions. One is cohesion and coupling, that you can see here. A good structured design is always follow the rules that will be includes cohesion as well as coupling. Then what do you mean by cohesion? Already you know the definition of it, right? Grouping of all the functionally related elements. That is what we are checking the potentiality of each element individually in the cohesion. In the coupling, we are making a communication between the different modules. Then how it's supposed to be? Very, very important, these two sentences here. Remember, a good structured design has high cohesion and low coupling. It's always should be like this. Highly cohesion. Individually it needs to be very potentially strong, and when it comes to the coupling, it needs to be low coupling. So when we are having more interaction between the modules, then the information hiding cannot be implemented. That is what the reason, high cohesion and low coupling. Then we can expect the information hiding in the structured design. This is how you are supposed to answer for this question. I hope you all understood. We'll see the second question here. Compare and contrast functional versus object-oriented design approach. So now we got to know regarding structure design approach. Next we have a functional and object-oriented design approach. So we'll see its comparison and contraction between those two types of design approach. So first here I have a comparison factor, functional oriented design and object oriented design. So on the basis of abstraction, so the basic abstraction which are given to the users or real world function in the function oriented design. When it comes to the object oriented design, so here the basic abstractions are not the real world function but are the data abstraction where the real world entities are represented. So what is the next parameter? That is functions. In the function oriented design, we are going to group the functions together by which a higher level function is obtained. When it comes to the object oriented, functions are grouped together on the basis of data. So here we are more emphasis on the data, here we more emphasis on the function. Next we have a state information. When it comes to the FOD, that is functional oriented design, State information is often represented in a centralized shared memory. So, the information about the state of a designing process will going to be shared in a centralized memory, but it will be in the distributed memory. And also, when it comes to the approach, this functional oriented design is a top-down approach. This object-oriented is a bottom-up approach. And also, when it will going to be begins by considering the use case diagram and the scenarios. Then in the object oriented design, we are going to design it, or beginning of that identification of object and classes. With the help of this, we will going to begin the design. Then how the decomposition will going to take place? In the FOD, we decompose in a function or a procedure level. Based on the function or a procedure, based on that, decomposition or dividing will going to takes place. So, we decompose in class level. Classes and object concept will be there in the object oriented design. And where we are going to use this? Mainly used for computation sensitive application. And this object oriented will going to involve system which mimics a business or a business case. There we are going to have this object oriented design. So, these are the differences between the functional oriented design and object oriented design, and it is for 8 marks. So, write all the 8 differences over here. Next, we'll see the question number 15. In that we have a sub question B. Explain top down and bottom up approach of coding techniques. So, you need to concentrate. They are asking about the coding techniques. We also have a design technique and system hierarchy, but they are mentioning as a coding technique. How top down and bottom up approach will be used for the coding technique, and it is of 10 marks. So, clearly you can understand 5 marks for top down approach and another 5 marks for bottom up coding technique. We'll see the first one with respect to top down programming. Mainly, this focuses on the use of modules. So, they are using modules in order to write the code or in order to do the programming. So, it is known as modular programming. That's why this top-down approach is considered as modular program. Programs are broken up into small modules so that it will be easy to trace a particular segment of a code in a software program. And also modules at the top levels are that performing a general task. When it is coming to the further levels, then it will going to perform a particular task. At the last stage, we will be having more detailing of a software, and each module will going to be based on the functionality of its functions and procedure. Mainly, this will begins from the top level of hierarchy, then it will further reach to the lower level. And also in this top-down module or a top-down programming approach, the risk of implementation of that data is somehow high, and also it will going to be helpful in order to have a global visible of all the functions and procedure. Along with that, mainly this top-down programming uses sequences and nested levels of command. So, this is what we are going to have in the top-down programming approach. And also next we'll go with the bottom-up programming. So, if you wrote all those things, you are going to get 5 marks. When it comes to the bottom-up programming, mainly it refers to the style of programming where an application is constructed with a description of modules. So, here it will be like this. So, we are adding the modules together, then we are going to get the higher one. In the same way, we are going to add it and we are get the higher one. So, this will be bottom up. If the direction is like this, then it is top down approach. So, the description begins at the bottom of a hierarchy and the progress row higher level until it reaches to the top, so that it will be more general at the lower level and reusable than the top-down programming. So, here I have listed out some more points with respect to the bottom-up programming, and here you can see that C++, Java, all these are the examples for this bottom-up approach, and it will be easier in order to add a new features in a bottom-up approach than in the top-down approach. So, wherever we have object-oriented programming, there we are having this bottom-up approach. So, this is regarding the answer for the top-down as well as bottom-up coding technique. We'll move to the next question, next sub-question, that is write a note on information hiding. This is for 5 marks. So that top down and bottom up programming is for 10 marks and this information hiding topic is for 5 marks. So now we'll see what are the content you are supposed to write. Information hiding focuses on hiding the non-essential details of functions and code in a program so that they are inaccessible to other components of a software. So mainly whenever we have the information hiding, it focuses on the abstraction. So we have to concentrate only on the essential features by hiding the non-essential features. So when we don't have a accessibility or if the user doesn't know what is there actually in the designing of a software, at that time it will be inaccessible. Fine. So we all know how to use WhatsApp. Do we exactly know how it is working internally? No, right? That is what they are having a information hiding or a abstraction, so that a software developer applies the information hiding in the software design and coding mainly to hide the unnecessary detail from the programmer or from the user or analyst that is not so necessary for the another person than the programmer. So the main objective of information hiding is to minimize the complexity among the different modules of a software. So mainly the complexity will going to be arise when we have an interaction between one and other modules. If we don't have an interaction, then the complexity will be minimized. Fine. And also information hiding is implemented with the help of interfaces. Mainly an interface is what? It's a medium or interaction for the software components that are using the properties of a software modules which contains the data. And also the implementation of that interfaces will always going to be depends on the process as well as the syntax. So in the information hiding, mainly we are focusing on the displaying of essential content by hiding the non-essential feature by the user. It's all regarding information hiding. And also I have listed out some of the points with respect to the information hiding. Write all these points in order to get 5 marks. Let me move to the last question, that is question number 16. In that first we have a sub-question A. In that first question, it's of 8 marks. Explain white box and black box testing. If you see the marks distribution, it clearly says that white box testing is for 4 marks and black box testing is for another 4 marks. We'll see the black box testing first. Mainly the technique of testing without having any knowledge of interior working of a application, then we will be calling that as a black box testing. So here we don't know how it is working internally. Being a user, I just know how to use it. So we are accessible only to its user interface. We are just giving an input and we are taking a output without the knowledge of internal working. And also in this black box testing, we don't have accessibility to the source code. That is the main thing. And here I have listed out some of the advantages and disadvantages with respect to the black box testing. So you need to write all the points here along with the disadvantages. So then you are going to get 4 marks in with respect to the black box. So we'll see the second thing with respect to white box testing. So when it comes to the white box testing, here we have a accessibility to the source code that mainly focuses on detailed investigation of internal logic and structure of a code. Only the programmer or a source code developer is able to communicate or to have this white box testing. And also we will be calling this as a glass testing or open box testing. There is no hide and seek in the white box testing. So we should know the internal working or a logic of a source code, then only we will be able to test that kind of any of a process or a product with the help of this white box testing. And also here I have listed out some of the advantages and disadvantages with respect to the white box testing. You need to write all these points in order to get another 4 marks. So write the definition, write its advantage along with the disadvantages. Then it will going to fetch you complete marks from a given question. It's all about easy question. Let me move to the next one, that is question number 2. Explain cyclomatic complexity with an example. And this is for 7 marks. So here if you are explaining, this will be for 5 marks. If you are giving an example, then that will be for 2 marks. Then what do you mean by cyclomatic complexity? It's a cyclomatic complexity of a code section is the quantitative measures of a number of linearly independent paths in it. So mainly in order to measure the complexity of a written code, we are going to have this cyclomatic complexity. So it's a software metric. This is also one of the software metric in order to indicate the complexity of a program. So how we are going to compute then? With the help of control flow graph or CFG of a program. So when it comes to the graph, there we have a nodes, and how we are going to connect the nodes? With the edges. So nodes indicates the smallest group of commands, and the directed edge, it will going to connect the two nodes. If the second command might immediately follow the first command, we wanted to communicate or we wanted to make a communication between the different nodes, there we are going to have a directed edge or a directed link which will going to create a relationship between the different nodes. So for example, if a source code contain no control flow, if you don't have any decision making or a control signals there, then the cyclomatic complexity will be remains same, that is standard is 1. So if a source code contain one if condition, so if condition or any branching condition, at the time cyclomatic complexity will be 2. Why? Because when we have a if condition, then there will be two parts. One is true or another one is false. For that reason, the cyclomatic complexity will be 2. So here you can see that in the structured programming, directed graph inside a control flow is the edge which is joining two basic blocks of a program as a control which may pass from first to second. Then how we are going to find the cyclomatic complexity? That too with the help of this formula, that is m is equal to e minus n plus 2p. So here e represents the number of edges in the control flow and n represents the number of nodes. So what are the different control flow graph elements that we have? That represents the n or a number of nodes, and e represents the edges. Then p represents the connected components. How many components is connected to that particular edge? That will be find out by p. So m is equal to e minus n plus 2p. So here what are the steps we have to follow? So when we have this cyclomatic complexity, construction of graph with nodes and edges, identification of independent path, and cyclomatic complexity calculation, then we have to design the test cases. So here I have one example. I am finding the largest of 3 numbers. I am assigning the value of 10 to A, and I am checking if B is greater than C. If it is true, then B will be considered as a large large element. Otherwise, C will be considered as a large one. Then we have to end if print A, B and C value. How it will going to be displayed? With the help of this control flow graph. So here 1, 2, 3, 4, 5, 6, 7. So totally here we have a 7 nodes, right? 1, 2, 3, 4, 5, 6, 7. So totally we have a 7 nodes, and how many edges we have? 1, 2, 3, 4, 5, 6, 7. So totally we have a 7 edges. Then how we are going to find the cyclomatic complexity? M is equal to E minus N plus 2P, right? So here 7 minus 7, edge is 7, number of nodes are 7 plus 2. That's what we are going to get the solution as 2. 7 minus 7 will be 0, 0 plus 2 is 2. This is the example which you can give in order to find the cyclomatic complexity. Then what are the advantages we have that I have mentioned here along with the disadvantages of a cyclomatic complexity. So if you written this much, then surely you are going to get 7 marks from this. We'll see the 16th question. In that we have a question B, that is sub question B, and that first we have a Cocomo model. Very important, not only with respect to this question paper. If you consider all the software engineering question paper, you can find this Cocomo model, very important. That is what Cocomo model is all about. It stands for constructive cost model. It is one of the very famous model which is mainly used to estimate the cost of a project. So, and also you can get the question like what are the different methods we have, or what are the different models we have in order to find the cost estimation of a project. There we have a Delphi model and Cocomo model. Then who invented this Cocomo model? By Barry Boehm in the year 1981. That's why it's also considered as a Cocomo 81 model. And mainly, this is mainly going to helpful for us in order to find out the or to estimate the time with respect to months and number of people, that is personnel or human resource members which is needed for the development of a project. And mainly going to be depends on the lines of code or KLOC, kilos of lines of code. Based on that, it will going to find out. And also, in this, we are going to categorize the project into 3 stages: organic, semi-detached, and we have a embedded. So, with respect to this Barry Boehm project cost estimation of this organic, semi-detached or embedded will going to be done with the 3 stages. Which are those? One is basic Cocomo, intermediate Cocomo, and at last we have a complete Cocomo. In each basic, intermediate or advanced or finalized Cocomo model, each stage you have to write its definition. Along with that, what is the formula we have in order to find out the cost, that you have to mention. So, mainly in the basic Cocomo model, it is just like a rough calculation of a software concept. We are going to use some of the constant values. Along with that, we are going to have certain baselines or a KLOC, that is kilos of lines of code. With the help of that, we are just finding the or just estimating the cost. So, here you can see that we have a expression. This is very, very important. E is equal to A into KLOC power B PM. E that specifies the effort which is applied per month, and A, B, C, D, all these are the different constant values. And also here we have a D, C into effort all to the power D months. So, D specifies the development time. We are finding what is the effort, what is the human resource we require, and what is the development time we require. And at last we have a P, that is total number of person which is required. How we are going to find that? Effort by time. So, for how many months, how many human resource that we require, that we are checking. When it comes to the intermediate Cocomo model, it is just an extension of previous one or a basic one. So, in this, we are going to use the cost driver attribute. Instead of only KLOC, we are going to have a cost driver attribute. With the help of this, we are estimating a cost. So, here you can see the formula, that is effort is equal to A into KLOC EAF. This is the only addition than the previous one. EAF is what? It is an effort adjustment factor. So, this is just a slight difference between the intermediate as well as basic Cocomo model. And when it comes to the details or advanced model, then it will going to combine both the basic Cocomo model as well as intermediate Cocomo model. So, with the help of that, we are getting or we are estimating a cost. And also we have a 6 phases in the detailed Cocomo that include planning and requirement, system design, detailed design, module code and test, integration and test, cost constructive model. This is also one of the important model, cost constructive model. This is also you can expect in your examination. Fine. This is how you are supposed to explain when it comes to the Cocomo model. Most oftenly it will be asked for your examination. And also I have listed out some of the advantages as well as disadvantages from the Cocomo model. Write all the content whatever you know. So based on the question and what they are asking. If they are asking a diagram, without missing off that diagram, you need to explain all the processes. And also I have listed out some of the limitations or disadvantages of a Cocomo model. I hope you all understood. With respect to this question, we'll see the next question, that is explain software configuration management, in short that is SCM. It's all regarding Cocomo model. Let me move to the last question of this question paper, that is question number 2 of B in the 16th question. Explain software configuration management. In short, it is SCM. So, why we require SCM or why we require management when we are doing some configuration changes with respect to the software. So, here SCM is a set of tracking and control the activities that begin when a software engineering project begins. So whatever could be the changes we are making with respect to the teams or goals, standards, or even objectives of a organization or an enterprise. So that needs to be managed well. For that reason, we have this software configuration management. It's a branch of software engineering mainly to provide a better process of handling, organizing and controlling the changes in the requirements, codes, teams and other elements in the software project development life cycle. Throughout the SDLC process, what are all the changes that we are making with respect to the goals, its objectives, team or any other element it can be. Whatever the changes we are making, that needs to be managed well. For that purpose, we have this software configuration management, and also mainly it will deals with the version selection, tracking the changes and version control of a software project with higher productivity and mainly to minimize the errors or a risk factor which is there in the software development. And also this output will be divided into three broad categories. One is what computer program, and it can be related to document or it can be related to data. So this is how you are supposed to answer. Along with that, the software configuration management or SCM is also considered as a set of activities that have been developed to manage the change through the life cycle of a computer software. So when it comes to the SCM or a software configuration management, it will going to have a multiple processes. In order to manage the configuration of a software, it will going to have a different process that includes planning and identification process, version control process or baseline. Very, very important keyword. Okay, and also we have a change control process, configuration release process, configuration auditing process, review and status reporting process. All these are the different processes which will going to be takes place with respect to the SCM or the software configuration management. So you need to explain 2 to 3 lines for each stages or each phase of this SCM. At last, I have mentioned some of the advantages. Tracking and managing the changes in a software process is easy. It provides the ability to enhance the productivity and provides a smooth workflow and easy to communicate and track every members of a team. So we are checking for the resources in all the stages, and also it will be helpful to update each team member's code parallelly by considering the different version control, and it will be helpful in order to manage or to control or to have a budgeting. So in order to do all these activities, this SCM will be very helpful. And also I have listed out certain disadvantages. It requires adequate resources. Software configuration management tools are required much, and it is also expensive. It requires more resources to work. So all these are the different disadvantages or a limitation which we can expect with respect to the SCM. I hope you all understood, and this will going to be helpful in order to make your exams easy. It's all about our discussion regarding the question paper solution of an year 2021 of November-December software engineering examination. Let me wish all of you all the very best. Let me meet you in the further session. Until that, keep learning, keep on growing. Thank you.